And good morning again. The following session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the first test. And I'm going to start with some questions that were given to me by email, and then I'll open it up for other questions that people may have. So the first question is this one where it says graph the inequality x minus y is less than -1. So x minus y is less than -1. All right. So I'm going to use the find 2 points method on this problem. And so what I'm going to do, I'm going to let y be 0 and find the x-intercept. So I'm going to get x minus 0 less than -1. Oh, wait a second. And finding my ordered pairs. Oops, I need to deal with it as an equation. So this becomes x equals -1. Okay. And then x minus y equals -1. We'll use x being 0. X minus y equals -1. 0 minus y equals -1. Negative y equals -1. Y equals 1. So we get these two ordered pairs, -1, 0 and 0, 1. Let's see, if I graph that just roughly here, -1, 0 is here, and 0, 1 is there. So 0, 0 is not on the line. Let's find out if 0, 0 would be a solution or not. So I'm going to take this and put 0 in for x and 0 in for y. And I get 0 is less than -1. 0 is not less than -1, so it wouldn't be here, it would be over on this side of the graph. Okay, so now I'm going to go to the WebAssign graph, and here's my inequality, x minus y less than -1. I'm going to use the line, not the dot, but the line. Click on it till it's blue. I have the point -1, 0 and 0, 1. Let's see. That was not, it did not include equal to, so it's going to be a dashed line. The point 0, 0 was not valid, so we need to fit it on the other side of the graph. So that's what that problem should look like. Let's submit the answer and see if everything's okay. And there we go. Any questions about that problem before I go on to another one? All right. Next one we're going to look at is not, I don't have it up there on the screen. I'm going to use the grid, but it's a different equation than what's up there. So we're going to look at this. It is 7x plus 3y less than 21 and 3x minus y greater than 3. So we're going to consider the solution of those two linear inequalities. Again, I'm going to use the ordered pair method. When I'm done, if anybody wants me to go back and use slope-intercept form, I'm happy to do that. So ordered pairs, I'm going to go ahead again and find the intercepts. Okay, so considering the equation 7x plus 3y equals 21. If y is 0, we get 7x plus 3 times 0 equals 21. So 7x equals 21. X equals 3. If x is 0, we get 7 times 0 plus 3y equals 21. 3y equals 21. Y equals 7. All right. If I make a rough sketch of that, let's see, 1, 2, 3, 0, 1, 2, 3, 4, 5, 7, 0, 7. I could choose the point 0, 0. I'm going to plug that back into my inequality. Maria, can you turn off your microphone? There's some sounds coming through there from somebody. Thank you. Okay. So if x is 0 and y is 0, we would get 7 times 0 plus 3 times 0 less than 21. 0 is less than 21. So we would graph on this side of that line. So I'm going to switch back over to the WebAssign screen and graph that first one. So, okay, let's see here. All right, so we have the point 3, 0 and 0, 7. It is not a solid line, so it's dashed. And we determined that 0, 0 was correct. So if I want to fill it, it would be that. So that's what the graph of 7x plus 3y less than 21 would look like. Okay, but we've got a second graph to do. Okay, so now let's take a look at the red inequality. And I'm going to do some erasing here so that I have some room. Okay. Again, I'm going to use the find 2 points method. And again, I think I'll use the x and y intercepts. So considering 3x minus y equals 3, if y is 0, we get 3x minus 0 equals 3. 3x equals 3, divide by 3, x equals 1. So there's one of our ordered pairs. If x is 0, we get 3 times 0 minus y equals 3. Negative y equals 3. Divide both sides by -1, and y equals -3. Again, I'll draw a rough sketch. Let's see. 1, 0, 0, -3. So 0, 0, again, is not on the line. If I plug 0, 0 in, let's see, let me create some room here. Let's go down here. So I plug 0, 0 in, 3 times 0 minus 0 greater than 3. 0 is not greater than 3, so we're not over here, so we're down below. Okay. So in fact, in both cases, it was below. Over here, it was below the black line. Over here, it's below the red line. So let's go back and graph. So I'm going to turn that blue. We've got 1, 0, and 0, -3. I see that both of these lines should be dashed because neither one of them had equal to, and they were both below. So this line would be below here and here. This line would be below here and here. So where do they intersect? Right here. Okay. Now, again, that inequality up there is not the one I'm graphing. Okay. But this is what the solution would look like. Any questions there? Does anybody want me to go back and do either of these problems using the slope-intercept method? All right. In that case, I'm going to go to some other problems here. Let's see here. Oh, no, that's not what I wanted. I had it. see here. We're going to go to problem number 9. Just a minute. Okay. So we're going to take a look at 9, 14, 15, and 16. Problem number 9, it says, find the first 4 terms of the sequence defined by a sub n equals 2n minus 5. Enter your answers as a comma separated list. Okay, now, so they're giving us a formula to use. It's not the usual arithmetic sequence formula. So we're going to use that formula. Okay. So a sub 1 would be 2 times 1 minus 5, which is 2 minus 5, which is negative 3. A sub 2 would be 2 times 2 minus 5, which is 4 minus 5, which is negative 1. A sub 3 would be 2 times 3 minus 5, which is 6 minus 5, which is positive 1. And a sub 4 would be 2 times 4 minus 5, which is 8 minus 5, which equals 3. So our answers would be negative 3, comma, space, negative 1, comma, space, 1, comma, space, 3. Any questions about that particular problem? So in each case, this n goes here. All right. Let's take a look at the next.
But we have to do it for 4 of them, not 5.
Yeah, that particular one, it said find the first 4 terms.
Okay.
Go back to the instructions so you can see that. So here it says find the first 4 terms of the sequence.
Okay, first.
Yeah, and I know, I understand, because a lot of them said 5, and so
Yeah.
when all else fails, read and follow the directions. Okay. All right, now we're going to look at problem number 14. And let's see here. So we can see 14. It says write, here it says write the first 5 terms of the geometric sequence whose 4th term is 7 and whose 5th term is 7 halves. All right, so we need a sub 1, a sub 2, a sub 3. We know that a sub 4 is 7 and a sub 5 is 7 halves. And we're supposed to write the first 5 terms, and they don't give us a formula, so we're going to use the formula a sub n equals a sub 1 times r to the n minus 1 power. Okay, let's see here. Now, I don't know what a sub 1 is. I don't know what r is. So let's see what I can figure out. Oh, to find r, I could take any term in the sequence and divide it by the previous term. So r would be equal to 7 halves divided by 7. That is a sub 5 divided by a sub 4. But that would be equal to 7 halves times the reciprocal of 7, which would be 1/7. 7 over 1 times 2 times 7 reduces down to 1/2. So r equals 1/2. Maria, again, could you mute your microphone, please? There's a lot of noise coming through, and I think it's through your microphone. Maria?
Yes.
Could you please mute your mic?
There's nobody in here. I'm in this classroom. It's just the heater that's on.
Okay, well, could you still mute it until you want to speak?
Okay, sure.
Thank you. Sorry, it's just distracting me, all these noises. Thanks you. Then when you want to talk though, go ahead and mute it.
Okay.
Here, I just muted it for you.
Okay, thank you.
Well, I did. There we go. Okay. All right. I feel so powerful being able to mute people. All right. So we know what R is. R is 1/2. Well, we're usually used to having like a sub 1 and then moving forward to a sub 2, a sub 3, etc. But now we're kind of actually moving backwards. A sub 2 equals a sub 1 times R, right? So wouldn't a sub 1 equal a sub 2 divided by R, going back the other way? So in other words, going this way, I'm going to divide by 1/2 instead of multiply by 1/2. Okay. 7/2, so a sub 5 divided by 1/2. 7/2 divided by 1/2 is 7/2 times 2/1 is 7. Okay, that's where we got that. Now, going here, 7 divided by 1/2. 7 divided by 1/2 would be 7 times 2/1 would be 14. Oh, what's happening? Isn't dividing by 1/2 the same thing as multiplying by its reciprocal, which would be multiplying by 2? You see what I'm doing there? In other words, moving forward, you'd multiply by 1/2. 56 times 1/2 is 28, times 1/2 is 14, times 1/2 is 7, times 1/2 is 7/2. Going backwards, you'd be dividing by 1/2 or multiplying by 2. So there, let's see, we're supposed to find the first 5 terms, and there they are. So we kind of have to work backwards on that problem. A little bit tricky there. Okay, we good to go on?
Could you try to do another one kind of like that? Because I'm lost, please.
Yeah, tell you what, let me come back. Well, let's see. Let me come back to that, okay? You remind me, because I'm going to have to go to a different screen and everything and then come back here. So just to make it easier on me, I will come back to another one like that here in just a bit.
Okay.
All right, we're going to look at, let's see here, 15. This is number 15 on the chapter review. Now, this may not look exactly like yours, but it's the same kind of problem. It says, find the first term of a geometric sequence if it has a common ratio of -2 and the 9th term is 32. All right, so we want to find a sub 1. We are told that the common ratio is -2 and a sub 9 is 32. And all we want is the first term. Okay. This is a geometric sequence. So a sub n equals a sub 1 times r to the n minus 1 power. Okay. So a sub 9 equals a sub 1, which we don't know yet, times r, which is -2, to the n minus 1 or 9 minus 1 power. So a sub 9 equals a sub 1 times -2 to the 8th power. All right. Well, -2, the quantity, so put parentheses around it, -2 to the 8th power is 256. So a sub 9 equals 256 a sub 1. But we also know that a sub 9 equals 32 from the given information. So that means this equals that. So our equation becomes 256 a sub 1 equals 32. We're going to divide both sides by 256. So a sub 1 equals 32 over 256. But I need to reduce that fraction down. Let's see. What goes into 32 that also goes into 256? Can you think of any number that goes into both? They're both even, aren't they? So wouldn't 2 go into 32 and also into 256? So if we divide the top and the bottom by 2, we get 16 over 128. Those are also both even. In fact, there's something larger than 2 that goes into both. Would 4 go into both of them? Can you see that? So if I divide the top by 4 and the bottom by 4, I get 4 over 32. 4 goes into both of those also. So I can reduce this whole thing down to 1/8, which is the final answer for 15. All right, we're going to look at 16, and then we'll go back and look at another example of problem 14. Okay. So here comes number 16. It says, find 2 geometric means between -7 and 56. So a sub 1 is -7. We've got 2 geometric means between that and 56. Okay, so we're going to use a sub n equals a sub 1 times r to the n minus 1 power, because it says geometric means. Okay. So I know that a sub 4 is -7 times n to the, r to the n minus 1, which is -7 times r cubed. But I also know a sub 4 is 56. So that means -7 r cubed equals 56. Divide both sides by -7, r cubed equals -8. Well, if we take the cube root of r cubed and the cube root of -8, we get r equals -2, because -2 times -2 times -2 is -8. So the cube root of -8 is -2. Well, now that I know that r is -2, -7 times -2 is 14, times -2 is -28, times -2 is 56. So the 2 geometric means would be 14 and -28. Okay, that finishes the questions by a student that emailed me. So now you wanted to look at 14, but with some different numbers. So let me make note here. This 14 has 7 and 7/2. So I'm going to go back in and pick some other, let's see here. Pick some other number 14. Let's see if I can get different numbers here. Yeah, wait. No, that's the same numbers. Okay, hang on. I've got to find one that has generated a different set of numbers. If I just make something up randomly, it might be pretty horrendous, so I'm not going to do that. Okay, let's see here. Let's take that one. Yeah. Hopefully they're not all the same. Here we go. Okay, here's one that's different. All right. So now it says, write the first 5 terms of a geometric sequence whose 4th term is 9 and whose 5th term is 9/2. Okay, so a sub 1 we need to find, a sub 2 we need to find, a sub 3 we need to find, a sub 4 is 9, a sub 5 is 9/2. All right, so let's go back here and take a look. So again, we're going backwards. So typically you find a sub 1 equals some number, and then a sub 2 is that number times the R, and then A sub 3 is that number times R, et cetera, et cetera. But if going this way, you multiply by R, going backwards, you would divide by R. Do you understand that part of the problem? Hopefully that's a yes. Okay. Now, to find R, we're going to take a term divided by the previous term, which is like 9/2 times 1/9, which is 1/2. So in this case, R is 1/2. So going this way, I'm going to divide by 1/2. 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 But dividing by 1/2 is like multiplying by 2. So what I'm going to end up doing, going backwards, is 9/2 times 9, 9/2 times 2 is 9, times 2 is 18, times 2 is 36, times 2 is 72. So first 5 terms right there. Does that make sense? So we've got to find R, but then we're going backwards instead of forwards. So instead of multiplying times R going forwards, we're dividing by R going backwards. Dividing by 1/2 is like multiplying by its reciprocal. So this times 2 times 2 times 2 times 2. Okay. All right. Do you have any other questions that you'd like to look at specifically today?
Number 11 on the review.
Okay. Can you just tell me what the problem is?
Yes, give me just 1 second.
No problem.
Okay, it says find the common difference of an arithmetic sequence if its first term is negative 535 and the 23rd term is negative 601.
All right, let me make sure I've got the information correct. We're to find the common difference, which is D, if the first term is negative 535 and the 23rd term is negative 601, right?
That's right.
Okay, we're talking arithmetic sequence. So the formula we're going to use is A sub n is A sub 1 plus the quantity n minus 1 times D. Okay. Now, we know that A sub 23 equals A sub 1 plus 23 minus 1 times D, which means A sub 23 equals negative 535, plus 22 times D. But we also know that A sub 23 is negative 601. So this equals that. Negative 535 plus 22D equals negative 601. To solve for D, we're going to add 535 to both sides. Let's see here. I'll use my calculator. Negative 601 plus 535 is negative 66. Divide by 22, D equals negative 3, which is all we had to do, right? Yeah. So we used 2 different ways of finding A sub 23.
Thank you.
You're welcome. Anybody else? Any other specific questions you'd like to look at?
There's one that I'm really struggling with on 14.3. It's find the first 5 terms. The first term is 4 and the fourth term is 108.
Read it again, please.
Hold on, give me 1 second. Let me find it. It says write the first 5 terms of the geometric sequence with the
okay,
following
okay.
properties.
Geometric. I didn't catch whether it was geometric or not. So a sub n is going to be a sub 1 times r to the n minus 1 power. Okay. I just wanted to make sure I had that it was geometric and not arithmetic. All right. So the first term is 4. The fourth term is 108. We need to find the first 5 terms. Okay. We're going to do something very similar to what we did a minute ago, but now it's with geometric sequences. So I know that a sub 4 is a sub 1 times r to the 4 minus 1 power. So a sub 4 is 4 times r cubed. But I also know that a sub 4 is 108. Therefore, 4r cubed equals 108. So 4r cubed equals 108. To solve for r cubed, divide both sides by 4, and we get what, 27? 25, yeah. So now, taking the cube root, r equals, what times itself is 27. 3 times 3 is 9 times 3 is 27. So now I know that r is 3. So 4 times 3 is 12, times 3 is 36, times 3 is 108, times 3 is 324. And there you have it.
Thank you.
You're welcome. Something else, anybody? All righty. Is there anything more you want from me? This is your time for reviewing. Let me just remind you of some things. In solving an inequality, if you multiply or divide both sides of the inequality by a negative number, change the direction of the inequality sign, change the direction, that is. When you're plotting inequalities in WebAssign, use the line button, not the point button. Okay. If it doesn't include equals, it's a dashed line. If it does include equals, it's a solid line. Okay. You're allowed, you can have a notebook card or a piece of paper that has these 2 formulas on it. Okay. But that's it as far as notes that you should be allowed. If you don't have a calculator, you can Google scientific calculator and use that one online, but that's all that you are to use online is that calculator. If you don't have a scientific one. Any other questions? All right, let's see here. Let me hang on a second. My email just clicked up, so let me see if somebody sent me a new email. It's just from the president, not that it's just from the president of the college having to do with COVID. All right, well, if you have no other questions, let me remind you. So today I will be here at 1:15 with an office hour. Tomorrow, there will be no 10:30 Zoom meeting. If you come to the Zoom meeting, there'll be a sign that'll say, no meeting today, take your test. You have until tomorrow night at 11:59 to complete the test. Once you open the test, time starts. So be sure to pick a time when you're not going to be distracted and you don't have to do something else. If you have kids, have somebody to take care of them, et cetera, et cetera. I know that's a dream, isn't it? Anyway, so I'm going to close up the meeting now and have a good rest of the day. I will see you either this afternoon or on Wednesday.